Welcome and thank you for joining again. We'll continue with a textbook question from page 114, number 11. So let's read the question first. For what values of a and b will the parabola y equals x squared plus ax plus b be tangent to the curve y equals x cubed at point 1, 1? So a lot of things going on here, so we're going to slow down and write the information down first. So let's start off by writing the equation of the cubic function y equals x to the power of 3. And we are told that we're drawing some tangent line in here at 1, 1. And we want this point, where draw the tangent in here, to be tangent to the parabola y equals x squared plus ax plus b. So let's try to picture this situation a little bit better. So I'm going to draw here the graph of the function y equals x cubed. So for the parabola to be tangent to this curve, it means that they have a common point of tangency. So in other words, wherever you draw a tangent here on x cubed, which is at 1, 1, that would be a point of tangency for the parabola as well. So the point 1, 1 is right here. So we can draw a tangent right here on x cubed. We know exactly where to draw the tangent for this parabola. Now, we don't know exactly the shape of this because we're missing two coefficients, a and b, which we can take the parabola anywhere on the Cartesian plane. So, but what we do know is that the parabola has to pass through the point 1, 1. So I'm going to draw an ordinary parabola here. It's kind of easier for me this way and to show this to you. And then I'm going to bring the parabola close to y equals x cubed. So, and touching the y equals x cubed also at the point 1, 1. So the tangent parabola means that this parabola here and this function in here will have one common point and one common tangent. So how do we approach finding the values of a and b? Well, first of all, whenever we talk about tangent lines, we're talking about the derivative of a function because it means the same thing. So we're going to start off by finding the derivative of the function y equals x cubed. So dy dx would be equal to 3x to the power of 2. And we'll say that the derivative exactly at x equals 1, that's where we are drawing the tangent, would be equal to 3 times 1 to the power of 2, and that will make the slope of the tangent equal to 3. So since the slope of the tangent on y equals x cubed equals 3, then we're going to say that the slope of the tangent on the parabola here will also be equal to 3. So therefore, we're going to say that the dy dx, the green dy dx, obviously, because they are two different functions, would be equal to 2x, that's the derivative of the first term, and then plus a, which is the derivative of the second term. So the value of dy dx would be 2x plus a, and it would equal 3. Now remember also that the point with coordinates 1 and 1 must satisfy the equation of y equals x cubed, so which means if x equals 1, y equals 1, and we can easily see that because 1 equals 1 to the power of 3. But it must also satisfy the equation of the parabola here. So we're going to say that if x equals 1 here, the value of y will also be equal to 1. So in addition, then we're going to say that we have another relationship to talk about here, and this would be 1 equals 1 squared plus a times 1, and then plus b. So that will make the value a plus b equal to 1 tick to the other side, equal to 0. So we'll say a plus b equals 0. And we get this by using point 1, 1 as a point on the graph of the parabola. Now, dy dx which is 2x plus a for the parabola, will have a value of 3, same as the dy dx for the cubic function. So remember that we are measuring this dy dx value where? At x equals 1. So at x equals 1, we'll say that dy dx here would be 2 times 1 plus a, and that would be equal to 3. So that means that we have 2 plus a equals 3. Right? So here goes another relationship that we disclosed between the slope of the tangent and the coefficients. And this is actually even a better equation because as you can see, we can solve for a, and a is 3 minus 2, or the value of a is equal to 1. So this will take us back to our equation that describes the relationship between a and b. We're going to say, wait a second, if a plus b equals 0, now that we know a equals 1, it means that the value of b must be equal to negative 1. So therefore, we're going to say that the coefficients a and b are respectively 1 and negative 1, which will make the equation of the parabola y equals x squared plus 1 times x, and wait a second, plus negative 1. Or even better, y equals x squared plus x minus 1. Now, just for the fun of it, we are going to draw the graphs of this parabola and the cubic function here, and check and see if it met, our design or our graph in here. So which kind of drew before we discussed the algebraic solution. So I'm going to start off with x squared plus x minus 1. And then we're going to draw the graph of y equals x cubed as well. X to the power of 3. And look at what happens here. So as you can see, this parabola will have the common point with the cubic function at 1 and 1. And you can tell that these two are tangent at this point. So if we were to draw a tangent line in here, then the tangent line will actually perfectly fit both graphs. So let's copy this so that we have a proper graph, a proper solution on our grid here. And voila! So we can draw the perfect tangent here. All right, let's make it. All right, so I hope this made sense, and I hope you enjoyed talking and understanding about these questions, and I hope that this can build some confidence in approaching thinking questions with more, with better vision. All right, bye for now.